Welcome back, everybody, to part 3 of the 1937 Silvertone model 4486. I kind of apologize. I thought I had put this out, but apparently I didn't. And I ran across some videos and I realized I didn't put everything out. So I'm going to try to piece this together and we will see what happens. This video will do some chassis work, some testing, and some chassis work. I really don't know what's on the video, so I'm going to try to piece it together and we'll see what it looks like. So here we go. Okay, I apologize for the camera work because I'm in workbench number 2 and I'm just not set up the video down here. But what I'm going to do is on this high voltage secondary I plan on checking. As you can see, I've already wrote a number down here. But what I'm going to do is I'm going to go from this point to this point and check it. And if you'll go to the plates 4 and 6, or pins 4 and 6 on the rectifier tube, we should see that. So let me do that. Up in here. There's one, and I should have put the one on the bottom first, so I'm going to anyway. Alright, as you can see, we're showing roughly 185, 86 ohms. Okay? Now, if we look at the center tap, here's where it gets kind of funky. The center tap, it goes up here, that's your B minus on all the tubes. You go down here, you go across here, there's the negative of one of your filter capacitors, and then the negative of the other filter capacitor. Now, this is a variable selectivity, and it's basically, they call it a 2-position switch, but it's actually a 3-position switch. When you swap between the police and foreign vans, you remove this particular resistor, this one right here. So otherwise, and that's supposed to be 330 ohms. You know, you see the W. There's the W. Everybody looks and thinks that's something else, but that's ohms. Okay, I believe that's a Greek symbol, or is it? No, there's something else. I'll put the explanation in here, but that signifies ohms. So if we were to go from one side of this to ground, we would see 213, which is higher. So that's reading that resistor. So let's go to this one side of this. Never fails, does it? Anyway, this resistor here, let's go to this side of it so that we're reading directly to the center tap, which pre-identified here, right there. And so now we're looking at 90 ohms to one side, so the other one's going to be, the other side is 96, 90, that's 185, 186. All right, so now if we, so we've proven each side equals that 185. So if we go to ground here, we're getting that 220, which one side through that, so that resistor is equal to, what is that, 123 ohms, 120 ohms or so, 90, yeah, I think so. Let me do some math real quick. Okay, the math is 123, so that means that 100 ohm resistor right here is 123. So if we swap this switch around until we get the other, we put that 330 ohms in there. Well, sorry for the glare. I went the wrong way, I think. There we go. Now we've got 542 minus 123. Well, let's see. Now let's do it this way. Okay. This one is on the side which is 96 ohms. So we take and we go 542 minus 96, and that's going to equal 446 ohms, which is 123. So we subtract 123, and we see that the other resistor, the 330 ohm resistor, is 323. So this all works out pretty good. The 100 is a little bit off. Was that 23% off? We can change that and life will be good. But this one is a little bit under. Of course, it being under, it may be something in parallel. So this particular, I believe this is correct. Now we go up here and we can check the 5 volt winding here, and then over here is the 6.2 volt winding that goes to the tube. So let me just check these offline, make sure they're good, and we'll come back and we will check this on pins 2 and 8, and then we'll go to another pin 2 and 7 on another tube and check this particular one here. And let me just check it. Well, let's just do it right here. We can do this. So we said it was going to be pin 2. Well, let's go to 8 since it's on the bottom. Hope you can see down in there. Yeah, let's see. Well, that's the ground. And pin 2 should be somewhere around less than 1, somewhere thereabouts. Sorry for the glare. That's 0.3. All right. Let's go over here. Pin just this tube right here. We'll go pin 2, which is here, and pin. Did I say 7? I believe I did. Yes. 7 should be here, maybe. And there's 1.8 ohms. So I believe that's correct. Now we'll go to the primary, which is here, and coming back from a switch somewhere. Let me find it. Let me locate it. Okay, I just tried to go across the power cord, and it looks like this is going to ground, but that is the way they've got the cord with a piece of wire. We'll have to reroute that. But anyway, I went up here and bypassed the switch, and we've got 4.5 ohms for the primary there. I rechecked that 6.3 filament winding, and I'm getting, I started 0.4 and now it's down 0.2. So I was showing 1 point something, but I believe that's more correct. But I got better continuity now. Sorry for the glare again. I've got to work out a better system down on workbench number 2. I was just going through doing some continuity checks on the IFs and everything, and I was going up here and checking the coils through the switches, and then when I got to this one right here, the broadcast one is open. Now the way I read this is coupled here. So the voltage, the high voltage, is supplied back to the plate of this RF stage here. And it's induced into this. These are fine. This one is open. And that would happen to be this particular coil right here. And I believe, the best I can tell, it is the top winding on here. If that's the case, I am going to attempt, it's a very fine wire, it looks like 40 or 40, it's at least. And I'm looking to see if I can see a break. But either way, this is going to have to come out. What my plans is to take the solder off the connections. There's 5 connections. And this is a spring. It's a T-shaped spring. So I think I can spring this up enough to bring it out. So we'll see. I mean, even if it's just a broken wire, this is one lead of it here to this one up here. So, and this length of wire goes inside the tube all the way up to the top part here. So it goes down and goes all the way up to this point up here. So if it's broken in here, it's still got to be fixed. Well, it's broken somewhere. So either way, this has got to come out to repair it. It could be, you know, could be a major issue. So we'll pull it out, look and see. That's all we can do, right? Okay, it's out. This is the front part of it, and I've made a mark on the top. Signify it's the top towards the front of the chassis, and the two should be this one, and they're open. And I'm thinking that I'm not sure what I think. I'm thinking it's this winding right here. That's what I'm hoping anyway. And we will see. We'll see what I can come up with. I believe the winding in question is this one here. There's approximately 12 and a half or so. It's very similar to the one on a field coat that I did several years ago. But anyway, the wire comes out here and goes in this hole, and then it goes all the way down the tube to this right here, which is a junction, which is one of the terminals. And then the other side of it goes right here. Find it here with my pencil. You can see how small this is. And this side of the coil comes and goes across and then goes to this terminal here. So this terminal, which is down on the bottom, and then this one that's up on the top, those are the two that is affected. So what I'm going to try to do, this looks like maybe some beeswax. I don't know if somebody's repaired it or if it was just part of the construction of it. So anyway, I'm going to take my hair dryer that I use, that I don't use, that I wish I could use, but, and then see if I can loosen all this up and probably end up rewinding this. But I need to look and see how it's wound and make sure I get it back in the same configuration. Okie dokie, I was unwinding this and I got about an inch or so, maybe about one turn. No, actually almost a turn. And as you can see, here is the end, and this is the other end where it broke. But if you'll look right there, and this is something you look for. I couldn't see it until I got to this point. If you see that little bit of green there, that is where moisture gets in here, and it's either a hot spot or whatever, I don't know, but over years this corrodes and then the wire fails there. But you can see the little green there. So what I've got to do is I've got to, before I go any further, I'm going to eat lunch. I got to keep my blood sugar up to combat levels, you know. But anyway, I'm going to find some wire before I go any further. And I've already counted these. It's about 12 and a half or so. And so I'll find some wire that's fairly close. I don't think it's going to be that critical, but you want to be as close as possible. And I'm not real sure of the gauge of this, but I've got some wire, some magnet wire that we will go back with. Once we get this off, we'll clean it up, and I may put down some double sticky tape on it to keep it in place as I'm winding, but we'll see if I can even find some double sticky tape. I checked the continuity of this with my voltometer, and I'm showing 1.1 ohm, and I checked it with my little magic box, and it showed 2.35. So we know it's very low resistance. So we'll when we get done rewinding it, we should have, I'm going to say roughly 2 to 2.5 ohms. We'll see, probably. So we'll see how that works out. Okay, I took the rest of the wire off, and then I took another piece beside it, and there was only one break in it. Usually you run into maybe 2 or 3, but there was only one. And so I've used all of it, and I've got the exact length that I want. I'm going to dress the ends, and then we'll start winding it. I put a piece of double-sided tape on there just to, and you can see where the windings were, but this will keep the wire in place as I'm winding the 12 turns. Okay, I've put that on there, and got it as straight as I possibly could, got it in the right direction. And I'm going to take and melt and put beeswax on it to protect it for another 85 years or so. And I've checked the continuity, and it's 1.46 ohms, which earlier in the video I said that the old one was 2 point something, but I checked it again with the ohm meter, and it was 1.5. So we're pretty close where we was at, and so I think it's going to work just fine. Let me seal this up, and we'll be ready to put it back in the chassis. Melted a layer of beeswax on it just to keep the moisture out, and moisture out, and keep it lined up. And I think that's going to work just fine if I can get this back in without tearing this or something else up. Okay, I've got it put back in. That worked really good. Those things are springy enough to be able to remove that. I've got it resorted, and while I was here, I replaced this 100K resistor and these 2 capacitors. So I left these. Someone had left those. They were out of the circuit, but they're braided or riveted to these shields, so I just left them in place. just like they did, and we'll call it legacy. It'll just be a whole lot of work to take that out. But initially when I was checking this, the police band was 0.2. And there's that glare again, huh? And then the foreign band was 0.2, the police band was 1.6, and then the broadcast band was infinity, and now it's 1.2. And that's at least it's showing. Now whether the coil works, we'll just wait until we try the radio. I think it's going to be just fine. Okay, this looks like a good place to stop. So, from Larry, from the hills of Tennessee, thanks for watching.